In this video we're going to look at maximum and minimum turning points. Another name for it is stationary points. Okay, I'm just going to point at this graph and I'll show you where its maximum and minimum points are. Its maximum point is here, its minimum point is here. Now I'm going to ask you a question about those points. What do you think the slope of the tangent to that graph at those points are? I'll draw the tangents to the graph at those points. There's one. There's the other. Now, what can you say about the slopes of those tangents? Well, the slope equals 0. So, at any maximum or minimum turning points, the slope of the tangent to the graph at those points is 0. So, in order for us to find the maximum or minimum turning points, I will differentiate the function. I'll let it equal 0 because that's the slope, and then I'll work back and I'll find the value that will give me the slope of the value that I can put in to get 0. Okay, it'll make more sense as I go through. This question here, that has a maximum and a minimum value. Alright, so when I differentiate that function, when I let the differentiated function equal 0, and when I work back to find out my x value, I will get two values. One will be a maximum value, or one will be where the curve is at its maximum. The other will be where its curve is at its minimum. Okay? However, something like this, that just has one value. So it'll either spit me out a maximum turning point if it was a curve like this. However, if it was a curve like that, well, then it'll be spitting out the minimum value. Alright? Just to go back on that again. Okay, let's take this one. I have my curve. I want to find its maximum and minimum values. I look down here. I'll differentiate the function. Then I let the function equal 0. And then I'll work back and solve to see what x value gives me 0. And let's just say it was x equals 1. And x equals 5. What that would mean is, if I go back here, x equals 1, x equals 5, that would mean that where x equals 1 is the one turning point, and where x equals 5 is the other turning point. Okay? It doesn't tell us though which one is the maximum and which one is the minimum. Only the x value where each can be found. Okay? Right. Let's look at this question then. It says find the turning point of 3x squared minus 12x plus 4 equals 0. If I was just to sketch that, alright, just think, what shape is it? Well, x squared, so it's quadratic. Is it going to be an N shape or a U shape? Well, it's a plus value here, so it's going to be a U shape. So this is going to have a minimum value. Okay? Right. So how do I find where that minimum value is on the x-axis? Differentiate it. So dy dx equals 6x minus 12. Let that equal 0. So look, I'm after differentiating it. Now I let it equal 0, and now I have to solve it. So 6x minus 12 equals 0, so 6x equals 12, so x equals 2. So what they're saying there is, on this graph, the minimum value there, okay, on the turning point, is at x equals 2. So if that's 1, that's 2. Okay? Now they're asking here, is this a maximum or minimum turning point? Well, before I even show you the exercise that we can do to find that out, intuition would tell us that it's a minimum point because we know the shape of the graph. So it has to be a minimum point, alright? But there is another way of finding it out. Okay, let's look at this. It says find the maximum turning point of this. X cubed, say y equals x cubed plus 6x squared plus 9x minus 7. So the first thing I have to do, anything to do with maximum or minimum turning points or stationary points, I'll differentiate. I get dy dx equals 3x squared plus 12x plus 9 equals 0. So differentiate, let equal 0, that's what I've done there, and solve this. So I want to solve for x. I can divide across by 3 actually to make it easier. Okay, so factorize this. X, 3, 1, plus. Split it, x plus 1 equals 0, x plus 3 equals 0. That means x equals minus 1, and x equals minus 3. Okay, but it says find the maximum turning point. But I have two values. So I need to find out which one is the maximum. I know one of these is the maximum and the other one is the minimum, but I don't know which is which. So we'll come back to that. Okay, now look at this, right? We'll come back to that question. I want to just go to this first. When we're determining the nature of a turning point, what I mean by determining the nature is seeing whether it is a maximum or a minimum value. Well, what we do is I'll differentiate the function twice. So look, I have my d squared y over dx squared. So I differentiate it twice. I'll put in then the x value. If the answer I get is less than 0, then it's a maximum turning point. Okay? Remember that if it's less than 0, it's maximum. You might be thinking if it's more than 0, it's maximum. No, if it's less than 0, it's maximum. If it's more than 0, it's minimum. Okay? And I would have spent a little while in class showing you why that is. Like why when it's less than 0, it's the maximum turning point, and when it's more than 0, it's the minimum turning point. Okay, but I won't get into it here. Right. So what I mean by that is, let's look at this function. And they're telling us its turning points at x equals 5 and at x equals 1. So they're telling us already. But they want us to find the nature of these turning points. They want us to find out which one is maximum and which one is minimum. Well, what I said is, we have to differentiate it twice. We have to get the d squared y over dx squared. So differentiate it twice. Well, if I differentiate it once, so dy dx equals 3x squared minus 18x plus 15. Now differentiate it again. D squared y over dx squared, and I will get 6x minus 18. Okay, so I'm after differentiating it twice, so I'm after doing this bit. Now I need to check my 2 points. So I'll check x equals 5, this one here. Okay, so this x equals 5, check that. So put 5 in for x. So we have 6x minus 18, so 6x minus 18, so 6 5s minus 18, 6 5s are 30 minus 18, which will give me 12. Now, 12 is greater than 0. So look back up here. We're looking for which is greater than 0. So look, greater than 0. If my differentiated function, my differentiated twice function is greater than 0, then that's a minimum point. So at x equals 5 is minimum point. It goes without saying then that at x equals 1 we have our maximum point. Okay, so going back to this question, we have 2 turning points. I want to find out which of them is the maximum, because I'm looking for maximum turning point. So what I have to do is take this function, y equals x cubed plus 6x squared plus 9x minus 7, and I need to differentiate it twice. I'm already after differentiating it once. I got 3x squared plus 12x plus 9. So that's dy dx. I need now to differentiate it a second time. And if I do that, I will get 6x plus 12. Now I want to find out which of these points, this one or this one, is the maximum point. Obviously the other one is the minimum point. So take my new function, the 6x plus 12, and I'll try minus 1. So I'll put minus 1 in there. So 6 multiplied by minus 1 is minus 6 plus 12, which will give me 6. 6, so I'll do it over here, 6 is greater than 0. Go on to this next page. So when it's greater than 0, it's the minimum point. We don't want that. We wanted the maximum point. So don't want that. That's the minimum point. So obviously then the x minus 3 will be the maximum point. But let's just make sure. Take our function 6x plus 12. Put in the minus 3, 6 minus 3 plus 12. 6 minus 3 is minus 18 plus 12, and that's minus 6. Minus 6 is less than 0. When it's less than 0, it's the maximum. Okay, we're not done though. Have a look up. They want the maximum turning point. We're after giving them the x value of that turning point. So if I was to sketch it, okay, so what was it? Next turning point minus 3. So watch now. Something like that. Let's say there was our max turning point. We found that that was at when x is minus, when x equals minus 3. However, that's not giving us the point. That's only giving us the x value, minus 3. How do I get the y bit? Well, what we do, we take our minus 3, we go back to the original function, we put minus 3 in for x. Okay, so let's do that here. This will give us our y value. So y equals minus 3 cubed plus 6 minus 3 squared plus 9 minus 3 minus 7 equals 0. That will give us y equals minus 27 plus, well, we have 3 squared is 9 multiplied by 6, which is 4, minus 7 minus 7. So get rid of that 0. Y equals, well, and that will give us, well, they'll cancel the minus 27 and minus 27 is 54. So we'll be left with minus 7. So y is 27. So the maximum point here is minus 3 minus 7. So in fact I'll have to re-sketch this. It'll probably look something like this. So the maximum point is at minus 3, I know that. Okay, so the maximum point is down here. The minimum point will be further down. Right, if you wanted to find out the minimum point, you could just take the x equals minus 1 and do the exact same. Put the minus 1 in there and it would spit you out an answer. Okay? Right. So I'll do a full question then. I'll do a few questions and hopefully that'll be enough for you. So find the turning points of the curve y equals x cubed minus 9x squared plus 15x and determine the nature of these turning points. Right, so the first thing we do is we'll differentiate it, let equal 0 and solve for x. So dy dx equals 3x minus 18x plus 15. Let it equal 0 and solve for x. I can divide across by 3 actually, so I get x squared. So x squared minus 6x plus 5 equals 0. I can factorize that, there's no need to use the minus b formula. Okay, so just to make sure that's right, x by x squared, minus 1 plus minus 5 minus 6, and minus 1 multiplied by minus 5 is plus 5. Let both equal 0. Therefore x equals 1 and x equals 5. So I know now I have two turning points at x equals 1 and at x equals minus 5. I want to determine the nature of these turning points. Okay. Now remember, I just have the values. Okay, I don't have the points yet. I have the values. So here, sure, why not? Let's get the points first, right? I have the values x equals 1 and x equals 5. So I'm going to put in x equals 1 into the function to get the y value. So we have x cubed minus 9x squared plus 15x. If we put 1 into that, so x cubed, which is 1 cubed, minus 9, 1 squared, plus 15, 1. This will give us out 7. So y equals 7. So one of the points, write it up here, is 1, 7. I'll redo that, but this time I'll put in 5 for x. And that will spit me out minus 25. So my other point then is 5 minus 25. Okay. Now, I suppose, just looking at those points, okay, looking at this one and this one. By looking at that, you could tell me which the maximum point is and the minimum point. Just have a look at the y value. The y value here is 7, the y value here is minus 25. Whichever the biggest y value is, that's obviously the maximum point. Okay, so if you look here, that maximum point there will be 1, 7. That minimum point there will be 5 minus 25. Okay, so that is another way of doing it, right? Just having a look at the 2 points and seeing which y value is biggest. So straight away I can say that actually that is the maximum and that is the minimum. All right, but let's just do it the other way. Okay, let's find out the other way. So I've differentiated once, which I got 3x squared minus 18x plus 15. Differentiate again and I get 6x minus 18. Take my x equals 1 and put it in x equals 1. So that'll be 6 1s minus 18. 6 minus 18 is minus 12. Minus 12 is less than 0. So therefore that is our maximum value. And likewise, if I put in 5 for the x, I will get 12, and 12 is greater than 0, so it's the minimum, which I suppose just reiterates what we said up here. Okay, so another question here. Verify that the curve y equals x plus 2 over 2x minus 3 has no turning point. So if it has no turning point, it's going to look something like maybe this, or something like this, or something like this, or something like this. Right? So no turning point. Turning point really means where a curve goes from an increase in slope to a decrease in slope, or from a decrease in slope to an increase in slope. Okay, and any of those last 4 graphs I showed you there, so this, provided it just keeps going that way, or this, or even this, okay, provided that it keeps going down the way, or a straight line, or a straight line up, they don't have any turning points. Right, so how am I going to verify that that curve has no turning points? Well, first of all, if you're asked about any of these turning points, the very first thing you're going to have to do is differentiate. So dy dx. Now, I'm going to have to differentiate this. You're going to differentiate that using quotient rule. Right? Now, I'm not going to go through quotient rule with you because you should know that already. I'm just going to say that when you do go through quotient rule, you will get an answer of minus 7, 2x minus 3 squared. Right. Now remember, to get a turning point, we differentiate and we let equal 0, and we solve, then we find out what x is. However, in something like this, okay, this function, we're never there's no number that goes in there for x that will give us 0. No number whatsoever. Because the only way a fraction can give you 0 is if the numerator is 0. If the denominator is 0, it's not going to give you 0 as an answer. Remember I said to you, if the denominator of a fraction is 0, the fraction blows up. It's discontinuous, right? The function is discontinuous. So if I look at this function, there is no number that I can put in here that will ensure my numerator is 0, because the numerator is always going to be minus 7. So I'll say this fraction, a fraction is 0 if and only if its numerator is 0. And in this case, it's not. Right? So I can get nowhere on this function is the slope 0, therefore it does not have a turning point. Second part of that question then, it says, and thus verify that the curve is always decreasing. Okay, well if the curve is decreasing, that means the slope must be negative. Okay, so if curve is decreasing, the slope must be negative. Right. Now, it says it's decreasing for all values of x, which means no matter what value for x we put in to this, the slope will always be negative. Now I'm going to write this as minus 7 over 2x minus 3 to be squared. Now, is there any value for x I can put in there that will give us a positive answer? If there is not, so if there is no value that I can get in here for x that will give me a positive answer, well then I can say the slope is negative for all values of x. And have a look at that. If I put in whatever number here, there's a square here, which means the denominator, so all of this is always going to be positive. Okay, so they're right here. The denominator is always going to be positive. If I look at this value up here, it's minus 7. That's not going to change, so it's always going to be negative. That means my answer is always going to be a negative answer, because I'm always going to have a positive on the bottom, I'm always going to have a negative on the top, so I'll always have a negative answer. Alright, so I can just say here, the fraction minus 7 over 2x minus 3 to be squared will always be negative. Therefore, the slope will always be a negative slope. Okay, and that's that done. Okay, now we're going to look at some kind of maximum and minimum type problems, right? They're kind of practical problems. Remember, anytime we're asked about a maximum or minimum problem, first thing is we differentiate the function. Second thing, we let the function equal 0. And the third thing then, we use that function to solve for x. These questions look a lot harder than they are. A factory produces n items, so many items per hour. The overhead cost is, okay, so the cost, the C stands for cost, the N stands for the number of items, is 400 minus 16n plus n squared over 4. Okay, and there's a euro sign here which doesn't really matter, we'll get rid of that, but just to let us know that it's cost in euros. How many items should be produced to keep the overhead costs to a minimum? Now, as I said, anytime you get questions like this, when you hear the word maximum or minimum, you need to differentiate. Okay, so we need to differentiate this function. Right, let's differentiate the function, and we will get, okay, so well, it's not dy, this will be c, so it'll be c dash n, just to show it's differentiated, which will be minus 16 plus, now if you're not able to differentiate n squared over 4, it's just 2n over 4, and 2n over 4 is the same as n over 2, okay? So plus n over 2. So I'm after differentiating it. I'll now let it equal 0. Okay, using a bit of algebra, I get n equals 32. Right. So I would presume then that in order to keep overhead costs to a minimum, I should produce 32 items. However, how do I know that's not a maximum? How do I know that this figure here is not the maximum rather than the minimum? Well, the first way I know is if I look at the function. It's a positive x squared function, which means it's going to be that shape which means the value it spits out will always be a minimum. But if I didn't know that, all right, what I would do is I'll differentiate this function again. So differentiate this. Okay, I have this one, I differentiated it once, I got this, differentiate it again, so I'll do that, and I get a half. Okay, now usually what I do is I take the 32, I'll put it into that function. If it gives me an answer greater than 0, it's a minimum function. If it gives me an answer less than 0, it's a maximum, sorry, not a minimum function. If I put the 32, I'll start again, if I put the 32 into the function and it gives me a negative answer, then it'll be a maximum value. If it gives me a positive answer, it'll be a minimum value. But in this one, there's just a constant, it's a half, okay? So there's no value to put the 32 into. Don't let that confuse you. Just look at this. Half, is it greater than 0 or less than 0? It's greater than 0. If it's greater than 0, then we can say it's a minimum value. And that's what we were looking for, wasn't it? Minimum. So now I can with confidence say n equals 32. So 32 items should be produced to keep overheads at minimum. Okay, last question. A closed rectangular box with a square base and size of x and a height of h has a total surface area of 54 centimeters squared. I'm just going to sketch that. Okay, I don't know how big h is now, like that, but here's the box. So I know that that's x and that's x, and I know that that's h, and I know that the total surface area equals 54. Okay, it says express h in terms of x. Okay, so total surface area of this equals, let's see, we have this side, which is x by h, and we've 4 of those, don't we? Okay, we've that side, we've this side here, we've the back, and we've the other side. Okay, so I'm down to the 4 sides, plus, and then we've x squared, which will give us this x by x, and we've 2 of them. So it'll be 4xh plus 2x squared, and that equals the total surface area, which is 54. And I want to express h in terms of x. So this is just a basic bit of algebra here, really. So I want h on its own first, right? So I want h on its own and everything else the other side. We'll have 4xh plus 2x squared equals 54. Right, well, if I divide it across by 2, okay, I get 2xh plus x squared equals 27. Okay. And then I can say 2xh equals 27 minus x squared. And then I can say h equals 27 minus x squared all over 2x. Okay, so there is my answer for the first bit. The height of the box in terms of h is 27 minus x squared over 2x. So that's the first bit done. Right, the next bit they ask then, express the volume of the box in terms of h. Well, the volume equals, I suppose, length multiplied by width multiplied by height. Well, volume equals, well, the length is x, that's this, the width is, we'll go dots, the width is x, that's this bit here, multiplied by the height. So volume equals x by x is x squared multiplied by the height. I have the height over here, okay, because I need to express all this in terms of x. That's what it says in the second part. So multiplied by 27 minus x squared all over 2x. Okay, so there's my answer to the second part. Here's the volume of the box. So that's that bit done. Second bit. Third bit. For what value of x is the volume of the box at its maximum? Remember I said anytime you hear maximum, differentiate and let equal 0, solve for x. So we take that function, v equals x squared multiplied by 27 minus x squared all over 2x. I want to differentiate that, so it's dv dx equals, okay, so I'm differentiating that, I'm getting the dv dx, okay. However, if we look at this function, I'm potentially going to have to use product rule first, okay, because it's two bits multiplying each other, the x squared and then this part of the function, and then with this part alone, this part highlighted, when I'm differentiating that bit, I'm going to have to use quotient rule. So it's going to be really messy. So I'm just going to have a look at it first to see if there's any way I can simplify this. If I can simplify it a bit, then I won't have to use quotient rule and product rule all mashed in together. Alright, so let's see. I have a 2x in the bottom and I have an x squared, so I can say 27 x squared minus x to the power of 4 all over 2x. And I can kind of start cancelling out in x's, so remember when I'm dividing by powers I minus the indices. When I'm dividing in indices I minus the powers, so that would be 27 x minus x cubed all over 2. Alright, now at least now I'm after getting rid of the product rule. I don't have to use the product rule now, so I could leave it like that and therefore I'd be using quotient rule. But generally I kind of like chain rules, so if I change it into this, then I can use chain rule. Okay, sorry, did I say chain rule for this? Okay, sorry, I meant product rule. Okay, so I'll be using product rule here. Look, I have a half multiplied by 27x minus x squared. So if I differentiate that, I'll do it over here. So half multiplied by 27x minus x squared. Right, well, here's our u, here's our v. I need to get u, v, du dx, and dv dx. I know the formula, okay, so you can look in your logbooks if you don't know it. Right, so u is half, v is 27x minus x squared, du dx, so a half differentiated is 0, and v differentiated is 27 minus so here we go, a half multiplied by 27 minus 3x squared, let it equal 0 and solve for x. We get, divide by half on both sides, we get 27 minus 3x squared equals 0. That will give us minus 3x squared equals minus 27. So 3x squared equals 27. X squared equals 9. So x equals 3. So just looking back at our question, it says, for what value of x is the value of the box at its maximum? Well, we found that out. 3. So, x is 3. Just sketch my box again. I know that's x, and this was h. Okay, so I know x is 3, okay, but I don't know what h is, right? But looking back, I knew that h in terms of x was h equals 27 minus x squared over 2x. So I'll be able to find out what h is now by putting in 3 for x. And if I work all that out, I will get 3. So h is also 3. So working out the volume of the box, then length multiplied by width multiplied by height, I will get 3 multiplied by 3 multiplied by 3, which is 27 centimeters squared. And there you go, that is that done. Okay, thanks guys.